we've been looking at different properties of functions and different properties of their graphs. Now we're actually going to look at a special type of function called a piecewise defined function. One thing I'll actually say right at the outset, and I'll say that repeatedly throughout the video and even in class, this is a piecewise defined function, which means it's a function. It's right there in the name. Which means when we graph these things, and that's how we're going to solve them, make sure what you graph is a function. Make sure it passes the vertical line test. These can be confusing, but if what you draw does not pass the vertical line test, then it's not a function, which means it can't be right, because we're trying to graph a function here. And the idea is, suppose I have the function f of x equals x squared. So, I'll give myself a lot of room now. I draw the parabola. We all know what the parabola looks like. It looks like that. Domain is all real numbers. Range is everything greater than or equal to 0. But for the sake of argument, suppose I said I only want to graph the parabola for the x's greater than or equal to 0. All I really have to do is say x has to be greater than or equal to 0. And then what do? I just erase the part of the graph that I don't really care about, where x is negative. Here I'll draw a closed circle because I'm including the point when it's 0. And now essentially I've restricted myself to positive values of x, which is not a big deal in the real world. In the applications we've done and looked at in class, a lot of times it doesn't make sense to have a negative x value, a negative domain, so we start our x's at 0. So that's completely fine. But then just for the fun of it, suppose I said I want to draw the absolute value graph. So I'll draw that, and I'll use a different color. So I start over here, I draw the V, and I'll just draw it like that for now. I'm going to have to change this because the colors are overlapping and all that. That's a terrible looking V. See if I can make it look better. There we go, that's a little bit better. But now I tell myself, you know what? For whatever reason, I only want to draw the absolute value for x is less than 0. What do? I erase all the x's that are greater than 0, which is this side of the graph. And now, essentially, I have the absolute value on one side of my axis, and I have the parabola on the other side of my axis. Does that form a function? Well, try the vertical line test? Sure. The only possible problem may be right at 0, where the two graphs are overlapping, but they're actually both equal to 0 there, so there's only one point. Which essentially means I've created a function. It's somewhat weird looking, but it is most definitely a function, and all I really did was take a graph I know and only draw half of it, take another graph I know and only draw half of it, and then stick them on the same picture and make sure they pass the vertical line test. That is all we do with piecewise defined functions. We take our f of x and we define it different ways for different intervals of x. But we make sure when we do it, you can really just draw the whole graph and then erase the parts I don't care about, so it's only defined on the interval I care about. The parabola for the x is greater than or equal to 0. The absolute value for the x is less than 0. So, suppose we have this one. F of x equals x cubed if x is less than or equal to 1, x squared plus 1 if x is greater than 1. Well, I start by drawing my axis. And now again, all I really do is, we use black and red, all I really do is, I draw the cubic graph for all the x's less than or equal to 1. I draw the quadratic shifted up 1, remember our transformations, for all the x's greater than 1, and I throw them on the same picture. The cubic, we know what it looks like. It comes up like this, it goes through here, and then normally it would keep on going forever, but now I'm going to stop it when x equals 1. When x is equal to 1, I get 1 cubed, so this is the point 1, 1. And I'm just kind of leaving off the rest of my graph. I'm going to draw a closed circle here, because I want this where x is less than or equal to 1, so I'm including where it's equal to 1. But then for my second graph, this is a parabola shifted up 1, which means normally the parabola starts at 0. Now it'll start at 1, and then it'll go up like that, but I'm going to restrict myself. If I drew the parabola shifted up 1, it would look like this. But I only want that picture for the x is greater than 1, so I erase it for all the x's less than 1. And then right here is where x is 1, and at the point 1, this is equal to 1 squared, 1 plus 1, 2, and I'm going to draw an open circle there, because here I want it for the x is greater than 1, not equal to 1, so we know from our intervals, that means I draw an open circle. And now again, essentially, I've drawn the cubic, but stopped it when my interval for x is ended for the cubic. Then I drew the parabola shifted up 1, but only drew it for the parts greater than 1. And I put them on the same picture. The last thing I care about is it a function? But if we do the vertical line test, everything is fine. The only possible problem is right here at x equals 1, but this point is closed, that point is open, so there's only one function value at that point, so it passes the vertical line test. I'm going to do one or two more of these just so we can see them worked out, but maybe we'll make them a little more challenging so you guys can see like more complex examples, which means I'll need more colors for my markers. So suppose I have f of x equals 2x plus 1 for x is less than or equal to 0, 3 for 0 less than x less than or equal to 2, and x squared for x greater than 2. Now it's a piecewise defined function, but it's defined over 3 intervals. So what am I going to do? I'm going to draw 3 graphs and put them all in the same picture. Let's see. So let's see, I can't use black, so red, green, and blue. We'll start at the top. 2x plus 1. That's the equation of a line, so I know it's going to look something like this. I only want it for the x is less than or equal to 0, so the easiest way to do a line is just graph the endpoints, or in this case, just graph that endpoint. At 0, I'm going to get 1. So at 0, I get 1. I draw a closed circle because I want it for the x is less than or equal to 0. And now we know the line would look like that because it has a slope of 2. But I only want the line for the x is less than 0, which is the x is over here. So I only draw that part of it. That should be good. Next up, green. Between 0 and 2, I'm going to get 3, which is just a constant 3. So when x is 0, go up to 3. If that's 1, we'll say 3 is right here. I'm going to draw an open circle because I only want it for the x is greater than 0. And then when x is 2, which we'll arbitrarily say is right here, I'll draw a closed circle. And then I connect the 2 dots. And there's my line segment. It's constant 3 from 0 to 2. Not including 0, so it's open. Including 2, so it's closed. That should be that one. Now for the last one. That's just the parabola x squared for x greater than 2. I know what the parabola looks like. I just need a starting point. Since I want it defined for x is greater than 2, I'll use 2 as my starting point. So at 2, I get 2 squared, which is 4, which we'll say is right here. I draw an open circle because it's x is greater than 2. And now in my head, I can see the parabola, but I'm just not going to include all the x's less than 2. And I'm going to continue the parabola for the x is greater than 2. And there we go. I would actually draw the parabola out and then erase the other stuff, but that's going to make this picture really messy and hard to see. But now, there's my parabola for the x is greater than 2. Open circle at 2, because it's only greater than 2. So that should be my graph. The last thing I check is it a function? But if I do the vertical line test, and if you're copying down this picture, I would suggest you pause the video right now and copy that down if you don't have it done already, because now I have to draw vertical lines all over it to make sure it passes the vertical line test, so it's going to get messy. But if I draw a bunch of vertical lines, clearly there's no problem. The only two potential problems are right here at 0 and right at 2, but that's why this is open and that's closed, so the function's only defined there, one place. Here, that's open, that's closed, the function's only defined in one place. So it'll clearly pass the vertical line test. The last thing I would say again is to reiterate what I started with. When you're graphing these, do exactly what I did. Graph each individual function on the interval listed, and then when you're done, check the vertical line test. If what you drew does not pass the vertical line test, it's not a function, it can't be right, because we're drawing functions. If it passes the vertical line test, it's not a guarantee it's right, but at least it's a function and you're in the right direction. There's one or two more properties of functions we want to go over, but I think this video is probably too long, so I'm going to end it here and start a new video for the last thing we want to go over.